Good evening, sir. Thank you for coming in time. Chalo, we'll start numericals today. Ready? First, take your note and come near, more near, so that I can be able to see what and all work you are going to do. Come on. So, last class we have studied about work, when work can be positive, when work can be negative, everything about work we have done. Now, today, what we are going to do is we are going to solve the questions related to it. Yeah. What the timing was. सूखना सी लड़की कौन है जब मैं ऑनलाइन देखा Now look here. We are going to start the class. Please understand this one. So a body of mass 2 kg is raised to a height of 1 meter. Understood? So a body is there. What is the mass of the body? 2 kgs. Understood? Is raised to a height of 1 meter. Find the work done by the force of gravity. Here what they are asking? Find the work done by force of gravity. So what is the work done by force of gravity? So if somebody will be asking you this question, finds the work done by force of gravity. A body of mass how much kg? 2 kg. So we know now, one thing we are knowing that 180 degree will be there because direct raising up. That time we have understood one thing, given a body of mass, whatever mass is there, let's check this one out. Okay. Let's see. So here mass is exactly given. So what is the mass given to you? Here vertically up. The body is exactly having displacement vertically up. So what is the displacement of the body? The body is exactly going vertically up. Vertically up means that means the body is exactly going like this, upside. So whenever it will be going upside, what will be there? Force, displacement will be there. Understood or not? So in displacement part, somebody will be asking you mass. Force is equal to mass into displacement, cos theta. So since the body is going vertically up, that day what did I say? It will become 180 degree. Understood? 180 degree. So work done will be equal to Fs cos theta. Force is equal to mass into acceleration. But here mass into acceleration, but here it will become g. G is what? Acceleration due to gravity. Here what will be g? 9.8. Always remember that when you are writing work done is equal to Fs cos theta and the body is going vertically up. Here the body is going vertically up. So since the body is going vertically up, it is exactly going to be called as Fs cos theta. Angle will be how much? 180 degree. Force is equal to mass into acceleration due to gravity, displacement, and cos theta is coming. Cos 180 degree. So cos of 180 degree is coming. So when cos of 180 degree will be their mass is how much given? 2 kg. Understood? So since mass is coming as 2 kg, acceleration due to gravity is 9.8 and cos of 180 degree. So here 2 8 16, 2 9 18, 1 19. So 190 this much into minus 1. So here it is coming as minus 19.6 joule. But work done cannot be considered as negative. Understand not? So we are going to find the magnitude of it. The magnitude of it will become 19.6. Understood? Good evening, dear Tanisha. Good evening. Good evening, Tanisha. माता गुड इवनिंग तो बोल दीजिए. Come on. Now this is the question and we have finished this question. Yes, good evening. Yesterday, one very big person was telling, I am coming offline, I am coming offline. I don't know where is that big monkey. Fine, we'll go for the next one, beta. So, this is exactly the way to do work done. Now, we will be doing work done for the next one. Now, go for this one and try to solve this question. A child pulls a toy car through a distance of 10 meters. Don't say if she will be seen means finally she is going to shout at me. Okay, you're calling me monkey. Okay, fine. We'll do that work, huh? Do that work means I will not call her monkey. Okay, fine. We'll do the work, huh? So now look here. A child pulls a toy car through a distance of 10 meters. Through a distance of 10 meters, the child is pulling a toy car. Fine. So after that, what they are telling that a horizontal floor, the string held in child hand makes an angle of 60 degrees. Bingo. So that day last class, now I have given you one very nice road map. In that part, I have explained you cos 60-degree value will be what. So at the time of solving, I will be explaining you. But force here is given. Force is given as how much? 10 Newton. Angle subtended is given as 60 degree and displacement is 10 meter. So now displacement is 10 meter and the work done is in the direction, means the force is exactly in the direction of displacement. So work done will be considered as positive here. Here work done will be considered as positive. Since the displacement is done, since the work force is exactly applying on the object and the object is moving in the direction of what you call movement of the object. So direction of displacement will be there. Understood. So now we are going to do this question. So now let's see how to solve this question. Some easy questions also I am going to solve and I am going to show you how to solve these questions easily also. Okay. Now look at. So in case of applied force, the displacement is not in the direction. So we calculate the work done by the formula. So how we are going to calculate? So here, what? So here it is going to come as force is exactly going to be what? 10 Newton. Displacement is how much? 10 meter was the displacement into 10 meter and cos 60 degree. You know what is the value of cos 60 degree? Cos 60 degree is 1 by 2. Cos 60 value, note down. Cos 60 degree value is 1 by 2. So once you are cancelling, it is coming as 50 joules. Understood? It is coming as how much? 50 joules. So this is the answer. It is going to come as 50 joules. Absolutely correct, beta. It is coming as 50 joules. Good job. So it is coming as how much? 50 joules. Done. This work is over. We are going to solve the next question. Let's see. 60. It is coming as 50 joules. So solution is given. So it is coming as how much? 50 joules. Okay. Now we are going to solve the next question. Get ready for it. This is question number 5. Now illustration 5. Come on, go for this question. Come on, go for it, please. So once this part we have finished, we will go to the next question. Our next question is, a man lifts 20 boxes, each of mass 15 kg. So 20 boxes, each of mass 50 kg. Wow. See, 20 boxes, each of mass, a man lifts 20 boxes, each of mass, 2 boxes also I can understand, 20 boxes. 20 boxes means 20 into 15, how much it will become? 300 kgs the man is lifting. Mama. So 300 kgs the man is lifting. It's gram or kg, yeah, to a height of 1.5 meter. Wow. To a height of how much meter? 1.5 meter. Okay. Find the work done by the man against gravity. So work done will be definitely negative, but this is too much, correct na? So 15, here it is written as 15 gram. There it is written as 15 kg. So we are going to do one thing. We will be taking grams only. Otherwise, Going down, going down. So here what are going to come here? So we are going to understand that the boxes is of how much? 15 grams. Understood? So the boxes is of how much? 15 grams. Okay. So 220, 100%, 225. 225 is so much. So here 20 boxes, 15 grams. Got it? So 20 into 15, how much it will become it? Yes. So here 20, the work done is gravity lifting a box is equal to how much meter? 15-gram box it is exactly taking, or 50 kg we will, because they are given in grams. After that they will get converted into kg, because kg has to be there now. Kg has to be there. If it is in grams means you have to convert it into kg, because kg is the unit. Kg is the unit. Standard unit is what? Kg. Standard unit is not grams. Okay. So we need to convert that first. But 20 boxes are there, boss. So 20 boxes means finally we are going to multiply with 20 boxes. So we know that work done is equal to what? Force into displacement. So displacement is how much meter? 1 point. Displacement is how much? 1.5 meter is the displacement. So how much is the force? First we need to find the force, because gravity we are going to take it as 10. Okay. So here what work we are going to do is simply see what it is written here. We are not going to go with that. What? Because it is quite confusing. 15 grams if we will take, the story will be different. Correct now? So 15 kg we will take, the story will be different. So let's take with 15 kg. What 15 kg is given? With the help of 15 kg if I am taking, so we know the formula, work done is equal to Fs. Understood? Cos theta angle is not given, so we will do F dot S only, work done. So here force is how much? Force is mass into acceleration due to gravity. So mass, if it is taken as 15 kg into displacement is 1.5 meter. So it will become how much meter? 22.5 kg meter. Understood? So it will become 22.5 kg meter, which is coming as joule. Got it? But how much we are going to take it as? You have in the exam tomorrow. All the best. Right, nicely. Okay. So now look at. So it is coming as 22.5 joules. 22.5 joules. But here one thing we missed now, acceleration due to gravity. Acceleration due to gravity is 10 meter per second square. So after that only this into 10 will come. So it is coming as 225. But here it's exactly about one box. Okay, it's exactly about how much box? One box. But how many boxes we are having? We are having 20 boxes. So work done for 20 boxes will be 225 into 20. Understood? Joules. So it will become 0, 0, 2 and 4, 5, 0, 0 joules. So it will be taking this much of energy. So this much work has to be done to take that boxes. I hope you might have understood here. So to take the boxes, how much energy is total needed? 4500. Okay, so this much of energy is exactly needed to pull the object up. I hope you might have understood the beta. Ninth class, where are the students here? Arnisha told she is coming. Where is she? Check her outside. Arnisha is waiting, or she came inside. She is not knowing where is the classroom. The previous question was based on graph, so we are not going to do that. Okay, fine. Kanishk also is not here. Done? So we are going to solve this question. Now look at it. A force of 10 Newton displaces a body by, force is how much? 10 Newton. Displaces a body by 5 meter. So 10 Newton displaces a body. Hey, wait. Where are you, Ray? You told you are coming offline. Not say your cough and cold was there, so you did not came. Now look here. Here the question is easy, beta. What they have exactly given you is they have given force. Force is exactly coming as how much, beta? Force is coming as 10 Newton. Okay. Displaces a body. So displacement is given by 5 meter. The angle between force and displacement is 60 degree. So angle theta is equal to 60 degree given. So find the work done. So we can find the work done very nicely because work done is equal to Fs cos theta. So here force is 10, displacement is 5 and cos 60 degree value. And here 50 into cos 60 degree value is 2. So we know that cos 60 degree is equal to 1 by 2. So it is coming as 25 joule. But is it easy? Is it easy? Oh, yo, sorry, beta, sorry. But you know, I'm telling you, monkey I was about to say, but after that, I saw this, I remember last time, one monkey was very angry on me when I called that person monkey. So after that, I did not say. Understood, no? We are going to go for the next question, beta. Okay, fine. We'll go for the next question. Come on. Easy na? So now, some numericals, we are going to use force and displacement related questions, na beta. It will be easy only, like degrees and all that questions will be there. Okay. So now we will be going for the next concept. Try yourself question. This PDF I am going to provide you in the group. Okay, so that you can try these questions. Now, work on all the three videos we are going to provide. We are going to study energy. Okay, but before doing energy, one question is there. You need to solve this question. Get ready. So this is the question I am writing, and you are going to supposed to solve these questions. Okay, the question is note down. A man exactly weight is 70 kg carries a weight of 10 kg. Man weight is हाँ, that man who is exactly going to carry the weight, his weight is how much beta? 70 kg. And he carries a weight, listen nicely, he carries a weight, he carries a weight 10 kg. So total weight will be how much beta? Total weight will be coming as, yes. So they're telling carries a weight of 10 kg on the top of a tower. The displacement means the person is going up is 100 meter. So the man carrying the weight is 10 kg and he is going exactly 10 meter up. Calculate the work done by the man. Calculate the work done by the man. So here we have to calculate the work done by the man and G. G we are going to take as 10 meter per second square. Okay. So this is G we have taken and we have to find the work done. Yes, hi sir, hi madam. I don't know your sir or madam, but from my side, hold about. Okay. So now this is exactly calculate the work done by the man. The work done by the man is Kutiji. Kutiji. Here Kutiji is not 9.8, here Kutiji is 10. Okay. And based on 10 only you need to solve the question. Come on, go for it. Huh? So now you need to understand that total weight is how much? Total weight is 80. So when total weight is coming as 80, how you are going to solve this? In the way you are telling is very funny. Thank you. So now listen. Here now they are telling a man carries 70 kg weight and it is exactly telling. So what we are going to do beta? We are going to convert it into final force. Okay. So we are going to write first force into displacement part will be there. So okay fine. Aja. The force is equal to Work done is equal to force into displacement. Hmm? Now, force into displacement means what you are going to do, the body will be exactly going up. So, force will be what? M into G into displacement S. Mass is how much beta? Beta total is 80. This is 10. And this is displacement is how much beta? 100. So, total it is coming as how much? 1, 2, 3, 4 joule. Got it? Hmm. That's exactly what you need to do there. So this is coming as 80,000 joule of energies. 80,000 joule of energy in carrying the person itself. The person itself is carrying himself and going by taking 10 kg. 80,000 of joules of energy. That's very big. Now look at it. 100 meter up. Happy monkey. Sorry. Arunesh. Mistake. Now we are going to go for the next part. So we are going to start. Oh, queen, princess, cool down. Orange color face is not looking good. Cool down, cool down. Chill, chill, chill. So now look at. Thank you. Now listen, Vita. We are going to understand about energy. So many people they are understanding that energy is what? Energy, a body is exactly possessing energy. Understood? So if somebody will say that I'm doing this work, so doing this work means in physics I have explained a very important point, and that important point in physics I have explained is कि whenever somebody is talking about okay, whenever somebody is talking about work, energy, anything, so we need to understand that ki whenever we are going to talk about work, energy, so you need to understand one very important thing that ki work is exactly done when you will have energy. Understand or not? So energy can be coming from external source, or energy can be coming from the internal part. Understood? So here we need to understand that the energy will be exactly coming from internal section means given a work is exactly you are doing. So somebody has given you a work of lifting weight, correct? Or you are exactly carrying some weight and coming from one place to another place. Understood? You are carrying a suitcase or you're doing some work. So that particular moment when you are carrying a weight or doing some work, that is also based on the energy what you are having. Understand or not? Now I will not give you food for 10 days and I will tell you carry 50 kg waste. 100% it is going to be a crime on me now, because I have not given you food for how many days? 10 days, and I am giving you work to finish it. Correct now? So first energy is possessed inside the body, and whatever energy is possessed inside the body, based on that work is done. So the energy will be totally divided into two segments. First segment is kinetic and second one is potential. Potential means what is possessed inside us is considered as potential energy, and the kinetic energy is due to the motion of the body. Understood now? So we are going to understand about work and energy relation. So in absence of energy, work cannot be done. Understood now? So if you have to slap someone also, you need external force. Understood? So force is exactly coming from where? From energy only now. So if you are having energy, then only you can slap it. Auntie, I have a doubt. A windmill is lifting water from a well. In this case, work have been done or not. Okay, so listen, nicely understand this one. In physics, see, work is done when you are waking up. What you are doing? You are sleeping on bed, and then something is coming in. Like when you are waking up, actually you are using your body energy and only na, and then only you are waking up. You are brushing your teeth. That means what? You are using energy, and every activity you are doing work. Understood? Sleeping is also work done. Talking is also work done. Fighting is also work done. So work is everywhere. But all the work cannot be considered as, in physics, it is not called as work done. Understood? So where energy utilization will be there, it is work. But till displacement is not there, it is not considered as work. I hope you might have understood. So displacement has to be there. Got it? For physics, displacement has to be there. Now you need to understand that when the windmill is exactly rotating, Understood? Now, the windmill rotating will be connected to a turbine. The turbine will be exactly connected to wheel. The wheel will be connected to small buckets, and the buckets will be rotating. Understood? So we know one very simple thing, that when the wheel will be rotating, the wheel which is connected to the turbine and the turbine which is connected to the windmill, if it will exactly keep on rotating, here displacement will become zero now, because every time the wheel is rotating and coming to zero. So here work is not done related to the wheel. I hope you might have understood. But if displacement will be there, then only it will be considered as work done. I hope you have understood here. So work done will not be there if you are talking about the windmill. So now we are going to understand one thing. So how can we compare two person? Yeah, windmill. See, when you are lifting water, when you are lifting weight from down to up from a well, so definitely then work will be done, because the bucket is going displaced, now the bucket is going up. That is a different thing. That's what I told. When the wheel will be rotating, means the displacement part will be coming as what? The displacement part will be coming as zero. That time the wheel is not doing any work done. Understood or not? So that time it will be problem. But if you will be talking about, if you will be talking about what you call, you are using a rope or something and taking out the water, that time displacement will be there, because the water is coming from bottom to up, the displacement part will be there. So here also now, when you are carrying a weight from bottom to up, that time also displacement part will be there, so work will be done at that case. Understood, Arun? I hope you might have understood this one. Now beta, we are going to understand one thing, that whenever we are comparing two people, how we are comparing two people? What is my mistake in this? Can you tell me, please? What I did? I understood the question. I explained you. You understood now or not? See, work done will be here. Windmill is rotating. That is a different thing. The wheel which is connected with the pipe and the pipe which is connected, that is different. Yes, now you understood now. That's it. Thank you so much. So now look here. You understand here, when somebody will be talking about what is energy. Energy is what? The capacity to do work is considered as energy. So anything which can do work is exactly having energy possessed inside it. Understood or not? So I told you one thing now, energy and work done, they both are binded and interlinked together. So if you have energy, then only you can do work. If you don't have energy, you cannot do work. Understood or not? So for doing work, you need energy. So energy is the energy is where possessed. It is inside the body only. Close kariye. Energy is exactly possessed inside the body. It is the intrinsic property with which we are doing some work. Okay. Now let's talk about it. When a car runs, the engine of the car generates a force which displaces the car. I hope you understood or not. So now energy will be exactly there. The fuel is exactly used. So here, see, if I will not put petrol in my car and I will tell my car to run, the car will not run. Correct now? Why? Because energy is needed. Got it? Energy is needed. If I will not give you food for 10 days and I will tell you go and run marathon, definitely the energy is not there. The fuel inside the body is not there. So if the energy is not there, you can't be able to run. Even you will not be able to talk also. Correct now? If you don't have that energy. Correct? So definitely when somebody will be talking to you about energy, so it is exactly what? It is what? What is energy? It helps the body to run, dance, work, everything. Na? What is energy? In physics, what they are saying, the capacity to do work is called as energy. Means when you have energy, you will do work. Correct? Na? If you don't have energy, you can't do work. Got it? So energy will always have the same unit as that of work. Work is exactly what? Work unit is joule. Hmm? SI unit of work is what? SI unit of work is joule. So energy SI unit is also joule. I hope you might have understood. Everybody understood this part or not? You say. So definitely, whenever we do any work, we will be needing energy. Yes, absolutely correct, Deva. So whenever we ability to do work is exactly coming as energy part. I hope you might have understood this one. So if somebody will be asking you, did I did any work? So if I'm standing here and teaching, am I doing any work? What work I'm doing? Teaching. Teaching is a work, but it is not a work in physics. But if I will displace from this place and keep on running, so if I'm doing, I went from that location to this location, if I will be displacing, just like understand here, I'm standing here, and from here I'm moved here. So this much displacement I done, so that is work. Understood? But if I'm totally standing here and blabbering something, teaching something, talking, joking, everything, but I'm not moving from my place, my work done is zero. Understood? Another time my work done will be zero. When my work done will be zero, I started from this point, I came to this point, again I return back to my same point. So that time my displacement will become zero. So since my displacement will become zero, my work done will become zero. I hope you have understood this one. So when the displacement is there, body will have work done. When the displacement is zero, the body will not have work done. I hope you might have understood this part. Come on, say. Understood? Yes or no? That's it. So here one more thing was there, na, that we understood. So force into displacement part was there. In that I have talked that given force and displacement will be perpendicular to each other, that time also work done will be exactly equal to zero. Yes, good, super. So now look here. So had the petrol tank empty, car could not run. The conclusion is that there is no source of energy to do work. So definitely when there is energy, there will be work done. If there is no energy, there will be no work done. So to do any work, what we need? Energy. And energy is coming from where? Inside us. Oh, energy is coming from inside us. Energy is coming from the food what you are eating. Understood? So there will be a chemical reaction. The food will be broken in your body into digestive system. The digestive system will break the food into water soluble particles. That water soluble particles will be carried out by the blood and go to the cells, and cells will have what you call oxidation, and then it will release energy, and this energy will be stored in the mitochondria. Understood? And at the time when you will be needing this energy will be available to you, and that only will be required for whatever work you are done. So for human, our energy sources, speaking, hmm? For human, our energy sources were better food. Absolutely correct. So whatever food we are eating, that is giving us energy. For car, petrol or diesel. Understand not? So vehicles, machines, either electricity will be a source of energy, or petrol, diesel, that can be source of energy. Understand not? Like washing machine. Washing machine source of energy is electricity. Correct? Car source of energy can be, yeah, either petrol or diesel in what they are working. Correct now? So that's exactly. So energy will be present there, and energy will only help. Yes, and energy will only help to do work. I hope you might have understood till here. So now look here, the above statement is not just true for above two examples, but it is true for all processes. Yes. So now we are going to understand about unit of energy. So what is the unit of energy? The unit of energy is same as that of joule. Sorry, same as that of work. The SI unit of work is joule. The SI unit of energy is joule. Understood? Because energy definition itself says that the capacity to do work. The capacity to do work is exactly considered as what? The capacity to do work is considered as what? Energy. Understood not? The capacity to do work is considered as energy. So here, whatever work you are doing, it is dependent on energy what you are having. So if you are having energy of, okay fine, I'll discuss with this. And now you are going to understand that in last class I discussed about Joule and Erg relation. Yes, I discussed about something. Do you remember that part? Now, if I will say anything means you will fight with me. Correct? Say so. I talked about erg and joule relation. I discussed. Erg and Joule relations I discussed. Come on, say. Yeah, no, say. Only A is not going to work. Say. Erg and Joule relation. What is that? Hey. Yes, A writing is not going to work. 10 to the power 7. 1 joule is equal to 10 to the power 7 erg. ERG. Okay, fine. We are going to start. You need to understand that Joule and CGS system, it is going to be erg. Understood? So now erg is dyne meter is exactly, yes, so 10 to the power 7 erg. 1 joule is equal to 10 to the power 7 erg. Last class itself we have discussed. So energy is a scalar quantity or a vector quantity. Energy is a scalar quantity. Work is a scalar quantity or a vector quantity. Work is a dot product of force and displacement. So since work is a dot product of force and displacement, it is a scalar quantity. So work is also a scalar quantity and energy is also a scalar quantity. Yes, 1 erg is 10 to the power 7 joule. Absolutely. Now you are correct. So now listen. 1 joule or 1 erg? Yeah, it is going to be a scalar quantity. Yes, so energy means what? See, 1 joule of energy is required to do 1 joule of work. So now you need to understand that energy is a scalar quantity and there are different type of energies. Understood not? Now, first is your friend and you are fighting. That time, what energy you are using? Verbal energy or muscular energy? Potential energy. Potential energy is energy stored inside the body, correct? But what energy you are using that time when your friend is fighting with you? Amma, correct. Super. Yes. So mechanical energy, I'm going to talk about mechanical energy. Energy by virtue of which a body can do some mechanical work. Understood or not? Directly is known as what? It is called as mechanical energy. What it is considered as mechanical energy. So now mechanical work when it will be doing means the energy when it will do mechanical work. Like washing machine. Washing machine is doing mechanical work now. What is the mechanical work washing machine is doing? Yeah, rinsing the cloth, cleaning the cloth. Understood or not? Mixer grinder is doing any mechanical work? Yes. Grinding work is done by mixer grinder. So it is a mechanical work. Understood? Fan is doing any mechanical work? Yes. Rotation is exactly the work of fan. So definitely all these are considered as mechanical work. Understood? The sum total of kinetic and potential. You remember always. So it is sum total of kinetic and potential energy. This should be in your brain. This should be in your content like the energy by virtue of which a body can do some mechanical work directly is known as what? Mechanical energy. And mechanical energy is sum total of kinetic energy and potential energy. It is sum total of what? Kinetic energy and potential energy. Kinetic energy is the energy possessed by a body due to its motion, and potential energy is the energy possessed by a body due to its position. Got it? So one is due to motion, another one is due to position. That's the difference. So the energy possessed by a body, yes, the energy possessed by a body due to its motion is kinetic energy. The energy possessed by a body due to its position is considered as potential. So if I'm standing in one place means my potential energy is exactly I'm using. But if I'm running continuously, that time it's not potential energy, it's the kinetic energy. So mechanical energy, if somebody will be asking you, it's the sum total of kinetic energy and potential energy. Now heat or thermal energy when somebody will be talking about, it is due to the temperature of the system. Understand? Not? So that means the energy will get converted into heat. Understood not? The system is exactly going to convert. So here the most important point is that whatever energy part will be there, that energy part will be exactly going to just transform into heat. Got it? So that time it's called as heat or thermal energy. Next is chemical energy. So if somebody will be talking about chemical reactions, in that chemical energy will be used. During what reactions? Chemical reactions. That time also in some types of the chemical reactions, they are exactly, consequently we can say that the chemical reactions can be, you can speak like that, the chemical reactions is having energy, and the chemical reactions can be exothermic or endothermic. Exothermic means the system will release energy, heat, in the form of heat. The system will release energy in the form of heat. The system will release energy in the form of heat, and the system will be exactly taking energy. So all the time it is not releasing energy. Sometimes it is taking energy also. I hope you might have understood. I hope you might have understood. So sometimes it is intake, sometimes it is giving. So there are some things which we need to understand into when we are talking about this. Super, very good, nice. Okay, now we are going to understand the second part. So now look here, chemical energy we have discussed about. Now comes sound energy. Oh. So you know what is sound actually? You are listening music. You are listening music now. What is music? What is music? What is music? I'm only hearing music. I don't know what is music. Idiot. What is music? First you think. What is music for you? And man, what is that? What is music? Her reaction is so good. What is music? Music is a type of vibration. We need to understand that. See, the string will be vibrating and it is producing. So when you touch a string, you are touch a string in a rhythmic way. Understood? So vibration will be produced. So that vibration is music. Understood not? So here vocal cord will be there. Above Adam's apple, here one vocal cord will be there. So how this vocal cord is generated? If my voice is like this, why my voice is like this? Because the vocal cord is exactly receiving this, it is exactly vibrating. Understood? So when I am taking air in, and at the time of respiration I am taking the air out. So at the time when I am taking the air out, see, if I will just do only one activity, I won't be able to speak. No, I just what I did is I took my tongue and I lifted into the lower side. So if I am not able to, so see, one thing is there that if I am not allowing my tongue to jump in and jump out, the total vibration is changed. Understood not? So the voice is totally changed. So here this is exactly what is sound. Sound is a type of vibration. So here this vibration is produced. So if you will continuously talk also now, you will feel very tired. Why? Because you are using energy. Understood? Because how much from this chest, how much air is coming out, that air is exactly using what? The air is getting used in vibrating the vocal cord. And this vocal cord vibration by changing a chapa 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 chapa, mouth, tongue, everything will be exactly making some specific sound. Understood? So sound is also a type of energy. Music is an art from whose medium sound and silence. Bah, super, very good. But music here is a type of sound, is exactly a type of vibration. Understood? Not? So when we are talking about vibration, vibration will be exactly doing what? The vibration will be disturbing the cord, and this see, the air which is coming out is going to disturb the cord, and at the time it is disturbing the cord, music is generated. That's it, and nothing else is there. Okay. So yes, so definitely this is the part. Now listen. Now electrical energy, energy flowing of electrons will be there in the conducting devices, will be again going to do what? It is going to electrical energy. When it will be talking about, it will be type of energy. Okay. Solar energy coming from sun is called as, the energy coming from sun is called as solar energy. The energy that is coming from nuclear reactor at the time of nuclear reactions, it is called as nuclear energy. Understood? So see, what is the difference between chemical energy and nuclear energy? What's that? Nuclear? What did you say? See, only one difference is there. In chemical reactions, the nucleus is not involved in reactions. So same element what is putting inside will come outside. But in a nuclear reaction, nucleus is involved. Understood? So nucleus will be bombarded with some very fast moving electrons, protons, neutrons like that. Understood? So that's why what is happening here is a new element is formed. So nuclear reactions are more powerful in compared to that of chemical reactions. How? I'll show you this. Wait. So see, Na plus Cl, it is coming as NaCl. So this is exactly called as what? Chemical reaction. So here sodium and chlorine was there. Sodium and chlorine combined together to form NaCl. No new element is formed. Same element which was there in the reactant came as product. Understood? So here no new element is formed. But if somebody will be talking to you about nuclear energy like uranium. So uranium U-235 will be exactly bombarded with neutron. So here barium, krypton plus 3 neutrons will be obtained plus tremendous amount of energy released here. Understood? So here did you watch one thing? Here uranium. What is there is uranium. The uranium is an element and it is radioactive, and definitely this radioactive element was bombarded with a fast moving neutron. Understood? So this neutron will break the uranium into two new elements. Understood? So this is type is called as nuclear reaction. So definitely nuclear reaction is having more energy in compared to that of chemical reaction. So nuclear reaction will be exactly of two types: nuclear fission reaction and nuclear fusion reaction. Fusion is uncontrolled. You cannot control it. Fission reaction is a controlled reaction. How we can control this fission reaction? So when this 3 neutron is obtained now, this 3 neutron will react with 3 uraniums. Understood now? Now each uranium after reaction will release 3 neutrons. Correct now? That means 3 neutrons. Now this 3 neutrons will again react with 3 uraniums. So it is very difficult to stop it. Got it? So this is an uncontrolled reaction. I hope you might have understood. So since it is an uncontrolled reaction, you cannot stop it. Got it? So what we are doing is, see, in this reaction, this 3 neutron obtained. After this 3 neutron obtained, we will capture the remaining 2 neutrons. So if we are capturing or slow down, if we are slowing the speed of the 3 neutrons by capturing the 3 neutrons, then it will be a controlled reaction. Then it is called as nuclear fission, controlled nuclear fission reactions. Understood? But fusion reaction is uncontrolled. What reaction is taking place in sun is a nuclear fusion reaction, where small elements are joining together to make a big element. So fusion is when two kuti elements will join together to make a big element. That is called as fusion. Understood? When a big element will be breaking into kuti, it is called as fission. So fusion cannot be controlled, but fission can be controlled. I hope everybody understood this one. Come on. Did you understood here, beta? I hope you might have understood this one. So this is exactly the way we can talk about nuclear fusion reaction and fission reaction. Is it understandable, or did I said anything which is not understandable? So I hope this much is clear to you, about nuclear fusion reaction and fission reaction. About sound and vibration, everything we have discussed with us. So we will go for our next short. See, they are telling about the correlation about work and energy. So, can you give me one example where work is done without use of energy? One example where work is done without use of energy. I asked a very simple question. You can't say that I did 50 joule of work. Correct, no? Instead of that, we have to say, we can't say that holding a box is many activities will be there. Yes, energy will be exactly possessed due to position. Also, energy will be exactly there. Where work done will not be there. Absolutely correct. Okay, but here, beta, one thing we must remember. One thing we must remember, like if somebody will be saying that I did work, we cannot say that we did 50 joule of work. No. So now we are only always saying that I am having energy to do work. Correct? What is the correct statement? The correct statement is I'm having energy to do work. Understood? So if I'm having energy, I can do work. But if I don't have energy, means I cannot do work. So it's energy which is responsible for letting a body do work. Understood? So energy can be different types, but definitely energy is needed to do work. Got it? So statement is apt on its own content. Understood or not? So now we are going to understand the next part. Now we are going to understand some examples. I need to read out some of the part. Understood? I need to read out some of the parts. Understood? So now look here. So when a fast-moving cricket ball hits a stationary the stump is thrown away. Understood? Here is the work is done on the stump by the ball, and the ball has the capacity to do this work. Understood? Because of the kinetic energy. Understood or not? So this kinetic energy, see the stump was having kinetic energy or potential energy? I which was having kinetic and which one having potential? Very good. And the ball kinetic energy is due to what? Ball got kinetic energy from where? From you. You used your energy. What you did? You used your energy and you have given the energy. So the ball is not having its own intrinsic energy. First, you need to understand. The ball is not having its own intrinsic energy. The ball has taken energy from you. Understood not? So you used what energy you were having, and that energy you have used in the ball, and the ball started rolling, and then it is getting the energy and getting converted into kinetic energy. The energy what you have given, the momentum what you have given to the ball is due to your energy. Understood? So exactly there is an external energy used. What energy used is external energy. So this external energy is given by you. Got it? It's not given by nature. It's given by you. Because ball, if I will not touch the ball, ball is a stationary object. What is ball? Stationary object. So this stationary object will ever be working without any energy, without any force? No. So exactly what you have done? You have used your energy in the form of force. And when you have used your energy in the form of force, what happened is the ball exactly started rolling. And after rolling, yes, absolutely correct, beta. So the after rolling, what will happen? Its kinetic energy will hit what? The stump. The stump is having what energy? Potential energy. Potential energy not due to its motion. Potential energy due to its position. Potential energy due to its position. And because of that potential energy due to its position, the body is exactly having what? Yes, I hope you might have understood. The body is now, the stump can be moved out. Correct now? The stump is exactly going to come out because the total force what you have given, the total energy what you have given to the ball has just passed that energy to the stump. Understood? So what energy it has received, it is given to the stump. I hope you might have understood. That's a pass on of energy from one source to another source. Understood? So maybe the ball got extra momentum. Correct now? So if wind will be there, you think in a non-windy day the ball will hit the stump, or in a very windy day the ball will hit the stump. Where resistance will be more? Very good. Because the wind will sometimes carry off the ball from one direction to another. Then the striking rate of the ball changes. Correct? No? So this is also some things which is very, very important. So the ball has the capacity to do this work because of its motion. And that is what motion is due to? Due to its kinetic energy. Due to its what energy? Kinetic energy. I hope you might have understood. A body can acquire the ability to work when it is deformed temporarily. For example, a compressed watch spring is able to drive the wheel of a watch. Correct now? We are compressing it. Good evening, Himanshu. So we are compressing it, and after compressing, what we are doing? We keep on compressing, and then we are releasing. What will happen? Tick tock, tick tock, tick tock, tick tock. It will start rotating. Understood or not? It will start rotating. Yes, Himanshu. It will start rotating, and then it will do work. I hope you might have understood this part. Is it ready? So climb upstairs to a high pitch, then work done by him would be mgh, and consequently he has lost mgh joule of energy. So definitely, Nabita, if I am standing in a place, and after standing in a place, listen. Oh, good. So now, after standing in a place, listen carefully. After standing in a place, I'm standing. If I'm standing for, see, in assembly, in school assembly, you are standing for 1 hour. Are you doing any work? Are you losing energy? Yes, because the entire energy what is possessed inside the body, you are wasting on stand. So not wasting, you are utilizing on standing there. Understand not? And listening some very good people thoughts. So whatever coming in their mind, good, bad, you are tolerating. You are experiencing that, not tolerating that. Understood not? So that is exactly what. That is also a type. Oh, very good, super. So definitely that is also a type of energy. I hope you might have understood. So this is exactly example of potential energy. Is it done? So see here, this part you must remember. That is, if a boy mass m climbs up stairs of height h, then what is the work done? Mgh is the work done. Understood? Force into displacement. Here force is mg and displacement is h. So that means beta how much energy it has lost? Mgh energy it has lost. To do work mgh, it has released energy of mgh. Now you understood. Mgh work done. That means how much energy lost? That's it. Got it? So if I done a work done of 10 joules, how much energy I have used? Now you understood. So how much energy is there, that much work can be done. So if I have 20 joules of energy and I have used, don't say anything. Okay. इसके बाद starting, I'm starting. Thank you for liking the class, and thank you for being in the session. It was indeed a very nice session now. नो कमेंट्स, पर्सनल कमेंट्स मत दिए. ठीक है. सो बेटा अंडरस्टैंड दिस. सो व्हेन वी आर डूइंग सम वर्क, मिस एनर्जी इज एग्जैक्टली यूटिलाइज्ड. अंडरस्टैंड नॉट? सो इफ आई हैव डन अ वर्क ऑफ 200 joules, means how much energy I have utilized? This is a very clear-cut core concept we need to understand. I hope so. I hope the session might have been very good. How was the session today? Was it wonderful? Did you learn numerical salt concept understood? Hmm? Beta, we are going to do work. Yeah, that's good. So if we are going to do what, beta? We are going to exactly start tomorrow again. Aru, you do one thing. Or beta, tomorrow you are coming class now. That time you bring what you have called NCRT book. Yes, maths. Surface area and volume we will be I will be seeing the book part, and then I will be teaching. That will be much better now. Correct now? Very good. Go there. Super. Yes, beta. Thank you. Bye bye.